your SDR.
That's right. But as long as he's okay with your purchase of the CNC, that's the first step.
Oh, yeah. Well, you tell her it's something for the garden.
Yeah. Well,
just wait for a couple more minutes. I know Dave is going to present some stuff tonight. I think Ken will have a little 2-minute chat, so I'll just wait for a couple more minutes for them.
I wonder why my camera's all pink.
Yeah, you are. Yeah. You need more light. You need more bandwidth. You need all kind, and you need a haircut.
Yeah, but I don't know. I'd say it's mood lighting, Hassan.
Yeah, the wrong mood though. If I was in a hotel,
I decided I better get a haircut just in case the lockdown happened, and so I did, and sure enough, it happened. So
yeah,
glad I did that.
Well,
yeah,
it's a
I just
perfect.
got my haircut a couple of days ago. The family was complaining. I don't know why. It's my head.
Yeah, why do they care? This is what I don't get. It's like
my bald son says my hair was getting too long.
Have you ever complained about like your wife's hair? Probably not ever, right?
Never.
Exactly. And you probably haven't complained about your son's hair since he was like 12 years old, right?
No. Well,
good evening, everybody. It's Wayne. My camera's not working for some reason today.
It shows that you've got it pushed off.
Actually, it's not allowing me to turn it on, and I checked it with my software on the machine, and it says you can't find the camera. So.
Well, anything. It says, yeah, here it says you've stopped it, but you maybe try going out and coming back in again, maybe, Wayne.
I did that actually.
Oh, did
you?
Yeah. How you doing, Wayne?
Pretty good. How's you guys?
Pretty good.
Good evening, Dave. Okay. Can you hear me okay, Dave?
Is Dave there somewhere? I don't see him.
Sorry? Can you hear me yet, Dave? Just all right. Well, I can see Dave's here, but okay, I guess we should get started. I guess Dave will speak up once he's ready to go. Okay, well, good evening, everybody. Thank you for joining us tonight for our AF Mixer for December. Please remember to mute your mics unless you have something to say. I promise I'll pay attention to the hand waving that goes on if you have any questions, and etc. Got the new schedule ready to go. I'll send it off to Peter Taylor for printing. Or not printing, but to put on the club website. But basically, it follows the same pattern as what we're doing now, and same thing with the controllers. If anybody has any interest in taking conducting a session, just drop me a line and let me know. Okay, tonight we got a few things on the go. Dave, whenever he gets He's back out again. He'll be talking about building the shack from scratch. Kevin, we got some stuff on taking notes and record keeping, etc. Michael's got a couple of things to talk about follow up from his common emitter amplifier presentation last month. And I think if Ken shows up, I think he's got a couple of minutes to talk about the DIS's DCR project, and I've got a little presentation that shouldn't take too long on how small can you go. Speaking of SMT stuff from a few moments ago. So I don't see Dave yet, so maybe I'll just start off and I'll go through the how small can you go, and then we'll go from there. Okay, let's. Okay. Okay, just got a message from Dave. He's rebooting, and for some reason my computer's taken forever to share the screen. Can you guys hear me?
Yep.
Okay. Yeah, it seems like my computer's gone into a bit of a lockup here.
If you want, Peter, I can talk about the note stuff. I mean, I'm just it's nothing formal. Just
yeah, sure. Yeah, go ahead, Kevin. You go ahead and do that, and then if all of a sudden my stuff pops up on the screen, I'll just cancel out until you're ready.
Yeah. Okay.
Okay.
Okay. Anyway, so I was gonna talk about this little project that I've been working on for a very long time that Peter knows about it, which is this CW trainer thing. And I was going to work on the modification. I had some modifications to do over the weekend, and I remember I had made some detailed notes about the little circuit board that I made, and just how I laid it out, and which was what. Anyway, and the wiring, but I couldn't find my notes, and I knew I made them, but they were gone. They disappeared into the ether. So that led me down another path, and it's kind of jives with something I've been starting on for work, and that is, how the heck do you keep track of notes? I don't know about you guys, but I got piles of paper all over my office. I got piles of paper for work, and now with this work at home, work at the office, back and forth, I never have the paper I need or the drawings I need or whatever. So I kind of made a bit of a, well, I'm trying anyway to go completely paperless for work, so that I always have all the stuff I need wherever I am, and it's always I always have it on the cloud, right? Through Office, Microsoft Office, the cloud drive. So, sorry, first things first. So anyway, what I started to do after this little debacle with my lost notes is, because I've got a few notebooks, around my office and stuff, and I thought, well, geez, what do you do with those? If you lose that, there's a lot of good information in there. How do you store it and all that? And I've been using OneNote sort of on and off over the last few years, not anywhere near its full capabilities. And you obviously need a Microsoft subscription. But so I just tried a few things. And let me see here. I was just enabling this as we were speaking. Yeah, okay. And it's actually working I'm surprised it's working as good as it is. So what I did as an experiment the other morning when I woke up too early and couldn't get back to sleep, I first of all, I bought a big tablet that I can write on. So I can use a pen, and it does, the handwriting recognition is amazing. It blows me away. And I can also mark up drawings. It's big enough that I can zoom in and mark them. Anyway, so that was one component of my work stuff. But as part of that, my tablet has like a scan type function. And I know there's apps for that, where you can take a picture of a business card or a letter or a piece of paper, and it scans it, makes it into a PDF, and then or a JPEG, and you can do whatever you want with it. So on that note, I took pictures of every page in one of my notebooks. I took pictures of every page, and I brought it into OneNote, and then I enabled. There's a feature in here where you can enable text recognition in pictures, and actually, it's not bad. So I'm just going to show you a couple things that things that I do here. Like I did one characterization of the Elecraft XG3 signal source versus my scope, right? The Siglent scope. And I just wanted to compare them and see, do they agree? That's all. And so I characterized that on some of the different frequencies and stuff. And anyway, so I made some notes for it, and yeah, okay. So anyway, sorry, I'm gonna share my screen here just to show what I've got. And the interesting thing about this is that once you make the text searchable, then okay, I'm actually surprised it's doing as good as it is, because I just enabled this when the meeting started, so it had to send all this stuff to the cloud and do its text recognition and all this. So can everybody see my OneNote screen?
Yeah, we can see it.
Okay, so this is like one page in there, and I just, I have a OneNote is broken down, and you can have notebooks, which is personal. I have a personal notebook, and then you have all these sections, and I have one section as Homebrew Tech Notes, and under the Homebrew Tech Notes, I have all these different topics. So one of the topics is like the SNA and Siglent scope and all this kind of stuff. So, but in here, so then if you want to find something, because this to me is the value of computers and notes and all this, if it's in a paper book, I can never find it, right? Or it's like, oh, was it this book or was it that book? They all look the same, anyway. So how can you find stuff? And the nice thing is, when you start typing, it highlights stuff in your notepad. So, if you want to, and whoops. Now it's going to find that one as the title, and it doesn't find all the text. It's not perfect, but it does go through, and it goes through everything that you've done, and it finds what it can. And some of it depends on how good your writing is. Maybe not all of it is done yet, like doing the text recognition stuff. So, but anyway, I was kind of looking at doing something like this, because it's like, this is what I want to do, right? Is have, and anyway, like there it's finding, power meter reference in one of my notes and other stuff. Anyway, so I just wanted to say this is what I'm going to try doing. And my question to everybody else is, A, do you keep notes? If you do, what works for you? Do you have something better than this? Like, I know there's other note-taking programs out there, like Evernote. I don't know all their names, but I know Evernote is one of the more popular ones as well. I mean, most of them require some kind of purchase or subscription. But anyway, so just an open question: does anybody have anything that they use better? Because my idea is that I'm going to take pictures of all these notes, get them all collated and searchable and all that. And that's at the end of the day, that's what I'd like to have then, is an electronic copy. And this is stored in the cloud. It's available on my phone, on my tablet, on my laptop, wherever I want it to be. And you can back it up. You can print PDFs of every notebook, and then you can have a PDF of everything. That's also searchable. So anyway, that's my 5 minutes.
Okay, that sounds good. I know I'd like to. I use notebooks, and I'm following the same problem. I got about 5 notebooks going on, and I don't know where I put what in which book. I thought I had a system, but I didn't. I did start making up a Word document, and then with the table of contents and all that kind of stuff. And I started to do that, but that was taking a long time, because now the notes can be really detailed. But the thing I liked about electronically was you could also put the schematics in there and pictures and all kinds of stuff. So I'm in between. I don't know what I'm going to do.
Well, and that's the beauty of this, right? It's like OneNote allows you to. Oh, okay. Now it dropped out. Yeah. It allows you to capture pictures and all kinds of other stuff, right?
Yeah,
you can cut and paste code, screenshots, whatever you want.
Yeah, no, and I think that's handy. Ken, you're first up.
So does it have to be pushed up to the cloud, or can you save it locally?
It does save it locally, Ken, but my part of my thing, and as tying in with my paperless, work from home or work from the office or work anywhere kind of thing is I just have it. I just put it on the cloud because then and then I have a backup. If my house burns down tomorrow, it doesn't matter. It's all there. I haven't lost anything.
Unless you lose your phone or your computer.
Yeah.
Well, I would have then I just buy another one and log into the account.
There you go. Dave, you got a question?
Yeah, let me lower my hand. Oh, no, there goes. Okay, yeah, so no question, just a comment. Yeah, Kevin, I use OneDrive. I started using it at the the job site I'm in now, and that's how I transfer my files between my computers. I don't bother syncing them up. It's all in OneDrive, but I use Box Cryptor. So it's a layer on top of OneDrive, and it encrypts everything that goes into OneDrive because some of the stuff I've got is kind of sensitive.
Yeah, you're in a different sort of situation that way, right?
Yeah, so that's what I kind of do. I've played around with Mind Map and a lot of other programs to capture notes. The problem is it's so time consuming to enter the notes, and having the handwriting recognition is cool, but good luck recognizing my handwriting.
Okay, well that's but I actually try to be I've been playing around with it on my new tablet, and it's like it's not faster than typing because I'm a touch typist, so I can type really fast, but it's still handy, and I don't write that neat, but it's still amazingly accurate. I am really impressed by how
What
good the
intrigues me
handwriting is.
What intrigues me though, Kevin, is what you're saying is a search, because that's the biggest issue I've got. Because I've got folders and folders of files and
Yep,
notes, and being able to go and
yep,
search to think,
ex-
okay, where did I put this file?
exactly.
So having that feature alone is tremendous.
Well, and that's why I thought I'd try this. It's like, okay, I mean, it's not perfect, but it's a whole lot better than saying, okay, I got a stack of 5 notebooks. Where is it?
Yeah. Hassan, you had a question?
I was wondering if you could use this with your phone because you
Yes.
don't need a tablet.
Yes, it can. You can use it with a phone as well. It's just I bought a large tablet just so I can do drawing revisions and review and stuff like that. But no, it works with any electronic screen device.
And do you have a stylus as well?
Yes. Yeah, I bought the big Samsung tablet with a pen. So, and the pen does some cool stuff on its own. Never mind just writing, but it's like you can pretend you're like a magician with a wand. You can control the tablet remotely and do stuff, which is it's nice, but it's like I really all I care about is I can write on the screen.
I just discovered graph paper from my CNC course. We were doing dimensional drawings and stuff, so we printed out. I actually found the perfect solution for me. I printed out colored graph paper on my regular printer with high quality paper, and it's fun to actually just sketch stuff out on that. But I think combining it with the camera and the OneNote might be a good idea.
Well, and the nice thing about OneNote is you can have a background of ruled paper, you can have a background of graph paper, and you can use that and you can write directly on it. And it'll even, if you're doing it not so much on the tablet, the Android app doesn't have all the functionality that it does on the computer, but it'll snap to like make nice rectangles and do like pretty fancy stuff if you wanted to.
Well, we'll see what you're like next month, how it's working out for you. If you're still using it, then it might be a worthwhile venture.
Yeah, no, exactly. It's a trial, right? It's like I've been using it for work for a little while, but not to its full potential. And I've decided I'm going to kind of jump in full steam and both feet and then see what happens. And then watch the cloud crashes and then my computer crashes and I lose everything and then I'm back to square one. So
Okay,
anyway, that's my experience.
Okay, thanks for that. Okay, I had to go and reboot mine. Mine locked up. I'll give it one more shot to see if I can do this, and then we'll bring Dave in. So let's see if this will work. Okay, can you guys see that?
Yes, sir.
Okay, so I just gotten into doing some soldering some small stuff of recently. So I put together just a little presentation here, and I'm calling it "How Small Can You Really Go?" And actually, you can go pretty small. My first go in this venture, the latest venture of soldering small parts, was the AD9850 DDS chip. I actually got this chip from Analog Devices years and years ago when I first got interested in DDS stuff, and it was a sample chip, and so we had it for free, but I never got around to mounting it on a board until just a couple of weeks ago. And you can see it wasn't too bad. I'm just off a little bit on the pad, but it went well and no shorts. And that was just basically. Actually, I can't remember if I just laid the solder to it. I think I actually went around and did one pin at a time on this particular one. I can't quite remember. And then, of course, on the right is your measurements, and that's a fairly big chip. It wasn't too bad. And a little bit smaller on this one here. If I guess you guys will, especially you, Ken, will remember the LTC 6900 chip, and so I put that on a breakout board so we could do the experiments. That's the DDS chip that we had in a sample pack from Linear Technology, and we were playing around to see if it would be suitable in the DCR PARC DCR project. And I didn't quite have the right breakout board for it, but it these pins lined up, except here. But it was no big deal because I didn't need the other trace that was beside it. So this pin actually got soldered to these two traces there, and it worked fine. And again, there's the dimensions here. And decided to go even smaller. And this particular chip here is an RF amplifier. And you will find this particular chip, you'll find in the hack RF on the front end. When you ask for a little bit of a preamplifier, this is the chip that does it. It also has a habit of blowing quite easily. I've been fortunate. I haven't been as careful as a lot of people, so I was surprised when I started hearing the horror stories about what they were doing, and they were blowing this chip, and I hadn't. So I considered myself lucky. One of the local guys here in Kingston blew his, and he ordered a bunch of these chips, and decided that he wasn't going to bother trying to solder it in there. And it is in the hack RF, it's a really, really tight spot. Anyway, he gave me the chips because he decided he wasn't going to go ahead with it and wasn't going to ask me to put it in there. And I decided to put it on a breakout board. And this particular chip, it's getting pretty small. This one here is 1.8 to 2.25 millimeters in the length, and I didn't have a 6-pin pad, but that's okay. And it was off center a little bit from crooked, but I didn't care because once I got one pin on it, and none of the other pins were going to short out, that was close enough for me. So I decided now I started to take a look for breakout boards that were going to take yet again an even smaller size, and they were getting a bit pricey, and I didn't feel like spending that kind of money on it yet. So I decided I think I'm going to try and make my own breakout boards. So here's my first effort. The pad on the left here is the SC70 pins package, and over here is the DFN, because now this board was going to be used for a digital capacitor on this side, and here was going to be the digital pot. This here didn't turn out very well, as you can see, and I figured it was because maybe my iron was a little bit too hot, and maybe I was pressing too hard, or a combination of that. So I didn't even bother trying to. There was no shorts, even though it looks like it. There wasn't any, but I figured if I solder something on there, I'm bound to have something happen. So I didn't bother using it. Now it looks pretty ratty, but I also didn't really care what was going on over here or here. I just was by this time I was only interested in the traces, and I started to thin them out a little bit here. I did have a break here in the pad. So again, I didn't use this particular board either, but I figure I was getting a little bit better because now I wasn't, I turned the temperature of the iron down and wasn't pressing so hard, and I was just doing it a little bit longer, leaving the heat on a little bit longer, but I was happy with the big improvement. This was the area here that I was most concerned about. So my third effort, what I done here, I just thickened all these pads up to these points here, all the way around, even over here. I wasn't being too making it nice and neat and tidy again, but I just, again, experimenting, and that seemed to work out pretty good. A little bit heavy here, but I did solder this board. So the chip I was using was the MCP 4018, which is the SC70-6 package. And this one here, the nominal is about 2 millimeters in the overall length, and 1.25 millimeters for this direction here. A little bit cockeyed, I guess, but it went on okay. No problems there. Works, no shorts. And over here, I went and made the attempt with the DFN, the digital capacitor. And as Dave predicted, it was going to be troublesome. And it did. I actually ended up lifting this trace right here. So I abandoned this idea. I haven't abandoned the idea of doing my own breakout and soldering it. I'm just going to take a different approach. And I haven't gotten around to doing that just quite yet. But I was pleased with what I was able to accomplish here. So here was my test setup that I did for the digital pot. There's the board there. There's the pot right there. And in this particular case here, the Arduino sent the code 6A, and this was 1.686, 1.6 K ohms, and it communicates by I2C. And that's it for now on that particular project. Stop sharing. So you can solder small stuff. You just gotta give it a go, and and you know what? You can buy some of these parts are really, really cheap, so you can experiment with you can try things out first. There's when I was getting down to the really small stuff, yeah, you're going to be wicking, just solder it on and then wick off the bridges, etc., that kind of stuff. But it can be done. So yeah.
Sorry, I'm raising my hand. I'm doing it the old-fashioned way.
Oh, I'm busy looking at the bottom left for somebody raising their hand. Go ahead.
No, you find the breakout boards that expensive? I mean, I have an assortment of them, but
I was looking for that particular footprint, Kevin. It was the SC70.
Oh, okay.
And they are not, you don't find them on eBay or anything like that. You have to start going to DigiKey, and then I looked at DigiKey Supplier and all this kind of stuff.
What about like PARC or something where you can buy very, very small boards, right? And they charge by the square inch or whatever it is, right?
I didn't look into that.
I've never ordered anything from them, but I've never heard anything bad about them. So, and it's all a lot of it's public domain stuff, right? So if somebody's done it already, you can just order it.
I'll take a look. I have not taken a look at that. When you're doing it on the Sunday afternoon, you want to get going on doing this thing.
You want to. Yeah.
What's your choice? I'll etch it.
You want it right away. Yeah, exactly. No, it looks like, and you've been etching boards for a long time, and you had difficulty. So somebody that hasn't etched very many boards like me would probably have a lot more difficulty.
Well, yeah, if your iron's too hot, you're pressing too hard, then yeah, that's going to be, that'll rear its ugly head big time when you're trying to do that kind of a footprint. If you want to get up into a little bit larger sizes, then you probably won't have that issue. But certainly when you're down the SC70 size, yeah, you need to have your technique worked out. But Hassan, you had a question?
Yeah, what temperature do you keep your iron at?
About I think it's 140. No, actually, I looked at the data sheet for the toner, and its melting point was around 140, if I recall correctly. So the iron's a little bit hotter than that.
Okay, and do you use? I heard that you can just kind of drop a solder blob on a board, like a commercial PCB, and it'll through surface tension, it'll actually line up on the pads. Is that?
Yeah, you can do that. You can put some solder paste on the pads and place your component, and you don't have to be 100% accurate. And then when you put it in the solder oven, it'll line itself up properly. Yeah.
Do you actually use solder paste at all? Do you find that useful?
I have not. The only time I used solder paste was when we did a club project, and the club has a solder oven as well, by the way. So if you decide to do something like that, you know, you can. I forget who's got it off the top of my head, but the club does. The homebrew group does have a solder oven available that lives in the Peel region. So that's no good to me.
I think solder has it.
Al, you got a question?
Yeah, I do. You're talking about ironing and putting resist on. I'm just curious what technique you're using. Are you ironing toner, or are you ironing the photosensitive film?
Toner.
Okay, very good.
I had read stories that brother toner does not work, and my wife happens to have a brother printer. I use a Canon, and that's what I've been using for years. So I tried one with the brother, and they're right. Brother toner does not work.
Oh,
Yeah, this week I just finished playing with the photosensitive film technique. Never tried that before, so I bought some and ran it through my hot laminator and exposed it, and not too bad actually. I haven't played with it too much, but it actually worked.
Oh, you're gonna have to do a little presentation on that sometime down the road, Al. Because I tried the method of running the PCB through the laminator and all that kind of stuff, and I found it really wasn't suitable for what I was trying to do for whatever reason. So I just went to the iron, and it seems to be working not too bad. Dwayne, you have a question?
Just a comment. If you're using toner transfer, I use the cold method with solvent, and I've been able to get down real fine chips with that. And one thing that does help though is if you go and run if you're using a laminator, you run your board through several times first before you put it on. Get the board good and hot before you go and try to transfer anything.
Yeah. I think we've talked about the cold transfer before a while back, but I can't recall. But I'm aware of it, but I've never tried it. But maybe it might be a worthwhile thing to try and just see how that method works out. Okay. Any other comments, questions? Oh, Ken, go ahead.
Simon has our club oven. So if anybody wants to use it, you can get in contact with him.
Okay, I'll make a note of that because we do have a database on the group's IO where any of the club equipment is, and whoever has it, it's identified in there. So I don't know if it's been updated or not.
Okay. And Dwayne, how do you do the cold method?
You mix up a solvent, this mixture of acetone, nail polish remover, and some alcohol. So just get to the point where it softens up the toner. Then you just apply pressure.
Okay, so what do? You print it out in reverse?
Yeah, the same way you would if you're using regular heat transfer. Only instead of using a hot iron to go and transfer it over, you basically put it on, and saturate your printed thing with the solvent mixture, and then just apply pressure.
Okay, I'll have to look into that. Yeah, the last time I actually printed a board or etched a board was in '82, but I used a photosensitive, and I used a shop ultraviolet machine to do it. And if I remember correctly, the board was perfect.
Okay. Anybody else? Okay, Dave, are you ready to go with the inaugural Show Us Your Shack?
Yep. Let me see if I can make this thing work. I was having problems with my PC tonight. And where am I? Oh, come on.
Share the application, not your screen.
No, it's the it had a little stupid little icon at the bottom of my screen showing the hiding where my application was.
Oh.
Can you guys see my screen?
Yep.
Yes, sir.
Okay, so this is, I put this together. Oops, I put this together. What the hell's going on?
It's getting better.
Yeah, so I put this together just to kind of put the chronology of what happened over the past year or so to kind of show you the evolution of my new shack. So the seed was planted, you know, all those trips down to FDIM and hanging out, you'll see one common face in all these pictures. And this guy planted a seed about retiring and all the benefits of doing this. So, you know, I decided to put my foot down and went to the wife and I said, wife, you know, I'm going to retire. And she ended up putting her foot down.
And you're not retiring.
So, you know, we had a compromise, and the compromise was you kind of work part-time, right? So I ended up, so I'm next year, hopefully I'm going to be working part-time. And so with that move, I sort of had to downsize, get out of debt and get ready for retirement. So, you know, I had the discussions. We had to have the planning and discussions going on with the various, you know, my key advisors. And so here's the shack I had. You can see here on the left-hand side, that's my radio. That's my old tuner there, my old ICOM unit at the top. Here's my Yagi. I had a TH3, a 3-element HF Yagi. And I had a remote shack switch at the bottom here to change antennas. And so my shack was fairly big, lots of stuff in there. And that's me. And yes, I had a mustache at one time in my life. So the initial work, I had to clean up the house, you know, get the house ready for resale. And in the process, I tried, you know, killing a few of the Gunter children. Here's the Gunter girl. You know, I tried killing her doing work around the house. She got smart and she left. The Gunter boy, he was a little bit more stupid, so I was able to do some damage on him. And so as I started packing my shack up to go, you'll see my shack here packing up, and you'll see slowly it's being packed up. And here it's the bottom right, it's towards the end. And it's pretty much empty for the move. So we moved, and this is a short little video here showing the new house, the basement. Before I took possession of the house, this is what the basement looked like. Can you guys see this okay?
Yep.
Okay. So you can see here, this is the roughed-in bathroom. There's some storage area here. And the key thing here is, I don't know if we're going to see it. Oops, oh shit. God damn it. I hate this PC. Oh my God.
See if we can do frame by frame.
Yeah, this thing is not playing very nice. Because, okay, what I wanted to show you here in this room, the floor joists are running this way, right along the floor. So it's perfect for me to run wires in. And then as I go over and I look at the rest of the basement, you'll see the floor joists are running this way. So the floor joists are running this way over in this part of the basement. And behind me, the floor joists are running in the opposite direction. So which makes it perfect for me to run cables in the ceiling. So you can see it's a large open basement. See, here's the joists running this way. And you can see here, these are gas lines, the yellow lines. And this is all the prior occupants' stuff in the basement. So this part of the basement, now you see the joists are running this way, but we've got a heating duct here, which had to be enclosed. So, you know, if I was to make a little bit of room here, I could make a raceway for cables. So I use this part of the basement as my shack. That's what I'm in right now. And so I used where that header is, that other part of the basement, I enclosed that and I made that into my office. So that's kind of the basement, the layout of the basement that came with. And then from the outside, then, you know, I looked at antennas. Where would I mount antennas? So a nice thing here is we've got this this pergola, or this trellis, and I've got some beams here. So one of the things I'm thinking of doing is attaching a mast to this beam here and putting my vertical antenna on top of that. So at this point I could run my vertical here, and you can see my backyard's tiny compared to the place I was in now. So this here, if you look here, you're not really getting a sense of it, but this is now the other side of the basement here. So this is where the furnace room is. So my idea was to punch a hole here, bring my cables out here, and you could see vinyl siding here. I would do a remote long wire antenna tuner and strap the antenna along the side of the house, just below the eaves trough, and run my antenna around the perimeter of the house, have my tuner here, then in this area put a ground shield, put a screen down, all from the back of this fence all the way back to the other fence, and that becomes my ground plane. So that's kind of my thinking of how I'm going to lay out my antennas. I don't have the antennas up, the holes drilled, the cables out, and also too here I was going to mount my remote antenna switch here so I could switch between my vertical and my long wire, and I'd use my long wire for lower frequencies, and I'd use my vertical for the higher frequencies. There you can see the vinyl siding there. So my initial move, then here's the basement now finished. Here's the room. I'm in finish. You can see the heating duct sealed in, and you can see some access panels I've got. So that's where my cable raceway is. That's where I'm going to run my cables along. This is just this room here at the back. It's a closet. It's a cold storage room. So I put shelves in there. I'm going to put all my junk. So you can see the shack evolving. So I started building my desk, my workbench. So here's half of my workbench. Here's the other half of my workbench. And here's the workbench completed. And I started mounting things up, mounting all my parts and things. And then I turned my attention to cabling. There's the hole going out. Remember last week we talked about, or a couple weeks ago, we talked about drilling a hole. So there's a hole there that I'm going to run my cable through. Here's the raceway, and you can see the pull string that I used to pull my cable. And that's the covering that covers the raceway there. Here's my remote antenna switch that's going to go outside. It's got 4 ports, and it's remotely controlled from this switch here, which will be inside my shack. So here's now running of the cables. You can see here's one raceway where the joists change directions. So at this point, the joists change direction here, and there's my coax cable there, and I also ran some UTP cable because I need to control the remote antenna tuner. Here's the cables coming out of the ceiling of my shack. Here's a picture of the cables running in the ceiling. And you can see it's running right beside my water pipes there. So it'll be nice and warm. And here's the cable going to the outside. So I put it in a nice coil to as a choke. I'll also put ferrites on the cable outside the house as well to act as a choke. And this is my Ethernet. This is showing my networking layout. I've got my Ethernet Cisco network switch there, my cable modem coming in, all my cables, and I've got all my walls. I've got all my cable, Ethernet cables all labeled nicely, very professionally looking. So here's now outside. You could see here the hole. This is where the cable comes out. And I followed Peter's advice about putting a box to pull the cable through. So you could see the coax cable coming out, going into the remote cable switch. And there's my UTP for controlling the remote, long wire tuner. I haven't mounted I just got my long wire tuner on Friday, and I'm just setting it up now. So, and here's the finished product. So this is my shack as is right now. I've put a big screen, large TV I'm using as a monitor for my computer. There's my computer there. And here's my bench. And I've got, another little table in the corner, parts, lots of space, floor space around. So I call this my noodling station. I've got a Linux box here, an old Linux box. And so here is where I plan to do all my noodling. So, and I've got my desk split up in terms of stations. So here's my soldering station. Here's my soldering iron, my hot air rework station, light, eyes, everything there. Here's my test station. So here's my spectrum analyzer, my signal generator, my scope. Peter, by the way, I turned on my spectrum analyzer a couple of days ago for the first time. I was trying to sweep my cables I was using to make sure my cables were good. I could not figure out how to use the tracking generator. It took me, I'm not kidding, it took me about 20 minutes to figure it out. And then here's my operating station. So this is where I'll have my my radio and my PC. That'll be running like a ham radio deluxe to control my PC. Here's my parts station. Here's just some storage where I got all my kits, and again, storage. And that's it. So now, there, I turned off my screen. So that's it.
That's pretty good, Dave. Nice big shack. I tell you, it wasn't too long before I built this one. I wish I was in a larger shack.
It's nice. It's nice doing things from the ground up, because then you could do things. I wish I had more time before moving.
Yeah.
Because between, I had to work, then I had to move, and I had to oversee the contractor building my basement, and then come and set things up. So I wish I had more time to
even if
do
you
things
had
a little bit better.
Be finished, Dave.
What's that?
Even if you had more time, you still wouldn't be finished, because you'd finish it and then you'd still want to make changes. But I like your idea of the noodling station. That's a cool idea.
Yeah.
Got a couple questions here for coming up. Al, you're up first. Did you have a question, Al?
Myself? No.
Oh, I thought you wait. Oh, maybe you're just wait. Maybe you're stretching. Okay, Ken.
Hey, Dave, you got the same backyard as I do, and I understand about the antennas.
Yeah, and so that's why, Ken, I'm looking at a long wire antenna. My friend in Ottawa, he uses that antenna, and my wire antennas I use on 80 meters and 40 meters, I get the exact same signal reports that he gets. And he's using just a piece of wire strung up in a bunch of trees randomly. It's not north, south, east, west. It just run randomly in trees. It's about maybe 20 feet into the air, at most 20, 30 feet into the air. That's it. And this guy works, he gets some incredible signal reports from just a wire. And I think the key thing is you got to have a good ground plane. As long as you've got a good ground plane set up, you're going to be able to get a signal out.
That's good. Any other questions for Dave? Comments? So who would like to? Oh, Hassan, go ahead.
I started to ask me, what's noodling?
I think that's a term that we picked up from. Was it from
solder smoke?
Yeah.
Yeah, that's a Bill Mara term. He says you got to noodle things. That's where you go away and you think. You do up your diagrams, you do your math, you do your calculations. You know, you got to noodle it. You use the noodle.
Okay.
Yeah, you were overthinking that one, I bet, Hassan.
He was thinking I was making ramen noodles.
Ken, you got a comment, Ken?
Yeah. So where's your long wire? Is it around the house or is it around?
I haven't put it up yet.
Oh, okay.
I haven't put it up yet.
So who'd like to show off their shack next month? Any volunteers?
Here's the wire. I got it measured. I measured it up the other day. It just now I got to go put it up and I put it together such that it won't tangle, but it's still tangled up.
You can't escape that.
Well, actually, there's a couple,
Yeah, the plan is, Ken, is to, because I've got vinyl siding, and is to just go and use some silicone and just put run the wires into channels and just put silicone to keep the wire in there. I don't want to put anything too I don't know, sticky or too much adhesive, because I don't want to damage the vinyl siding, because if I have to go sell the house, I don't want to have to go replace it or take a hit.
Take some advice from me. You're there for life. You're not moving.
I'm going to move from here. Trust me.
Man, in the old folks home.
Back to Bolton?
Man, no, not back to Bolton. In this neighborhood, you take a stone, you throw it, you can hit a kid.
So your antenna's actually going around the house, right?
Yeah, around the perimeter. That's the plan.
Okay, I thought maybe the house would cause interference with the antenna.
It might.
Kevin, you got a comment?
Yeah, how much power are you running, Dave, when you're running the antenna around the house? Do you have you thought about RF safety? Just asking.
Yeah, I don't know. I'm thinking. Well, I have my unit runs 100 watts, but what's that going to do?
You're probably okay, but if you're like, mind you, you're not doing like, hours of transmitting at 100 watts, right? But still, FT8 stuff is like, if you're running that high a power, I think you might want to consider it, depending on, is it close to a bed or something like that near an outside wall?
Well, it's near my kid's room, so he'll have 3 eyes.
Well, if you don't want to give away your inheritance, then you're probably okay. But Eric, no, just something to think about. That's all.
Yeah, no, it's a good point. It doesn't matter. Any antenna you got close to the house. right, is gonna cause that problem, right?
And you're like only inches away from them. If their bed is at an outside wall, their head is only inches away from that wire, and they're in the near field. So
Yeah, because there's
just a thought. That's all.
Because there's absolutely nothing else I can do to put an antenna up to get down the low bands unless I put a vertical, put one of those verticals and I load that up with the antenna tuner, because the remote tuner I got,
Use an RA line.
it can, here it is here. So this, the documentation shows that you can drive a vertical with it.
Well, or the other thing is run it around up in the attic, but run it around the edge of the attic.
Well, that's a good point.
Then at least you're probably 6-8 feet away from normal bodies for any length of time.
Yeah, but you know what? That's a good point. Those people that put antennas up in the attic, isn't that going to radiate back into the house?
It does, but no more than what you're going to do.
See, I don't know if you could see the picture here.
No, it's not very clear.
Yeah, there's a picture there where it shows the vertical mounted on a bumper of a car.
Oh yeah, right, yeah.
And the key thing they were saying in the documentation is ground plane. You got to have a good ground plane for these antennas.
Well, it reduces your takeoff angle and gives you better.
Well,
transmission,
RFI
right?
too.
Yeah.
Because apparently those antennas are famous for putting RF on the shield, right?
Oh, the verticals?
Yeah.
Yeah.
No, any kind of long wire where it's not a dipole.
Yeah, exactly. No, well, the outside of the coax is the other half of the dipole.
Right.
So the other thing is run your coax down. Actually, they were talking about this in a podcast the other day. I was listening to it. And this guy sells the pack antennas, right? That's one of the things that he makes. And what he suggests is, so you got a long wire, and once you put it on the ground, it's very lossy. It doesn't matter. But if it's up in the air, it's part of the antenna. And he said what he does is suggests is put a choke, like a ferrite core choke, on the outside of the coax, somewhere down away from where the wire is attached to the coax. So effectively, you've created a dipole. Half of it is the outside of the coax, the other half is the long wire.
Yeah.
And so that if you're running your coax, say, up to the long wire on the side of the house, well, then where it exits the house, maybe you could put a couple of chokes or ferrite cores, clamp them on the coax, and then your coax becomes like a vertical part, and then you've got it like an L antenna, right? Inverted L.
Yeah, because I looked at all these antennas they put up in attics, and I saw people loading up eaves troughs with antennas, as just a random antenna. And I saw lots of that stuff, and I thought, well, why couldn't I put a wire around the outside of those?
You can,
but yeah, your point about near bedrooms is a good point. The only place at the back of the house is spare bedrooms, right? So we're not living. My wife and I don't stay in those rooms.
So you just fry Eric, that's all, when he stays over.
Yeah, that's right. That's Eric's room.
Or me and Bonnie.
And speaking of Eric, Eric, you had a comment?
Unmute.
Can't hear you.
Unmute.
Can't hear you, Eric. No.
No, he's having problems with this video or audio.
He had nothing profound to say. Okay. All right. Well, that's great. Now we just got to find somebody to volunteer for their next shack display. Oh, Ken, you have another comment?
Yeah, what are you using for a ground plane? Is it a matrix of wires or just?
Yeah, it's screen.
Okay.
All I did was I took screen.
Okay.
I took screening, and I put, because at the back of the house it's all weeds. It's all weeds there. So what I did was I just put screen down, and there was a fire pit, which I dug up. I didn't want a fire pit because it had a whole bunch of stones. So that's all, and a garden. So all that I'm planning to put sod down on. So the sod's going to go on top of the wire mesh.
Okay.
Okay. Thanks, Dave. and then we'll try and see. Nobody here has volunteered yet so far for next month, but we'll find somebody to show us their shack. Okay, Michael has a follow-up to his presentation last month. There are some discrepancies. I've forgotten what they were now, but I'm sure Michael will refresh our memory. Floor is yours, Michael.
Okay. Yeah, I'm going to just share my screen here. Application window. Yeah, last time I talked about this common emitter amplifier, and we were chatting about gain and whatnot. And what I had done, I set this thing up on a breadboard, and I did some scope stuff, and this here, and this shows this is a 7 megahertz signal to go from 3.5 megahertz to
recording is on
to 25, and yeah, how you do that is you set up, maybe you guys know this, you set up this AC analysis thing, you decide whether it's going to be an octave sweep or a dB sweep or other a decade sweep, and I'm still not clear exactly what all that's about, but anyway, put in the start and stop frequency, and it calculates this, it produces this spice operative, and that shows up below the voltage source here. So anyway, what I had done before, I had done this is the bottom curve here is what I had before, and this is the frequency across the bottom, gain here plot, and it showed at 7 megahertz, which you can see here the gain was 28 dB, and I was questioning, well, why was that 28 and not closer to the 37 that I got here? And I suddenly realized afterwards, that actually a couple of days I was thinking about this, and when you set up the simulation, what it's doing in the circuit, it's taking this voltage, setting it at 1 volt for the frequency sweep, the voltage source, and it sweeps the frequency. And what you do is you measure the output over on the output of the circuit, and what you're looking at is the gain between the input voltage, the 1 volt here, and the output, or the ratio of the two versus frequency. And what I realized was, thinking about it, that this series resistance you assume is a problem, because if you assume 50 ohms in series with the voltage source, and the voltage source is 1 volt behind it, then that 50 ohms is going to degrade the performance that you see. Whereas what you're doing when you use an oscilloscope, you're actually measuring the output voltage here and comparing it to the input voltage to the circuit here, because that's where your signal generator goes, and you measure from here to here. So the way to make LT Spice do it is to reduce this resistance to a low value, and that's what I did. And you can see the difference here. The upper trace here is with a 1 ohm source resistance, virtually nothing. So what you're seeing at the 1 volt part of the circuit on the signal generator here, inside here, it's essentially the same voltage right here as you're putting into the circuit. So when you're measuring it with a scope, you're measuring from the input from here. And if you set up the LT Spice generator model properly with the very low resistance here, then the voltage behind this, the 1 volt, is essentially still 1 volt here, as opposed to being much lower because you've got a high resistance in here. So anyway, having done that, I got 37.5 dB or 37.7 dB at 7 megahertz, which compares with the actual breadboard gain of 37. So that sort of explains why I was not seeing the gain. This is the LT Spice gain, and it wasn't consistent with reality, and that's why I discovered, at least I think that's why. So that's really what I wanted to show you guys.
Well, that makes sense because, like you said, you were measuring the actual voltage going in, whereas you were decreasing it with that 50 ohm selection. Dave, you had a comment?
Yeah, Michael, what I do a lot of times is I actually use LT Spice, and I measure also too, by you removing the load, you may be causing some kind of mismatch in your circuit. But anyway, what I do a lot of times is I will measure the output voltage terminated and measure the input voltage after the source 50 ohm internal impedance. I measure the voltage in, voltage out. I do the control click, whatever, to get the RMS value, and I use that to identify the gain.
I'll have to think about that. What are you doing exactly in the circuit here? This is the
You
this is the circuit, right?
do a regular AC analysis. You're not doing a transient. You're not doing the gain, the bode. You're not doing the bode plot.
Yeah, you're just doing the sine wave in and out kind of thing.
Right. And so you measure the sine wave at the source, measure the sine wave at
Like
the
here.
output.
Like here.
Right. Yep. Measure it there, and then measure it
Over here.
at the output. Get the RMS, get LT Spice to give you the RMS value. Divide output divided by input. Do your dB calculation, and typically a lot of times I'll use that approach.
Okay. But you do that basically with a sine wave input, sine waves out, and getting a sine wave output, right? That wouldn't give you the frequency response, but it would give you the gain. Yeah.
Right, because don't forget, this is not. It's not a bode plot is giving you the frequency of the gain over time, right? And it's giving you the phase shift over time, right? So over frequency, sorry, not over time, over frequency. But when you do it my way, you're doing it for a specific frequency. You're saying at 7 megahertz, this is the gain.
Yep. Which should be consistent with what you're looking at here.
And it will be. And it will be.
Yeah, provided you measure. Yeah. Okay, got it.
I have a comment on your measurement of the your noisy signal there on your second slide, Michael.
This garbage, yeah.
What are you using for your probe? Are you using the ground wire, or are you using the paper clip or the spring clip?
Actually, I just use the probe, normal spring clip and the ground wire, and I guess I could that may cause some problems too. Yeah.
You're using a spring clip?
No, I was not.
Oh, with that low voltage, I bet you a lot of that noise will disappear if you get rid of the ground wire and just use the spring clip on it.
So the little tiny clip that goes over the probe, that's the ground. I see.
That's right. Yeah.
Yeah, Michael, I found my scope. I think you got the same scope I have.
Yep.
I think the lowest signal I can really, see and is readable is probably in the 20s, 20 millivolts or something like that, right?
Yeah. So this one's 31. And to get that 31, I used the FieldTech signal generator, which I used, hang on a minute. I used 20. I used about 12 dB attenuation and a little attenuator I built to knock down a 0.7. I think it was 0.7 volts showing on the signal generator to knock it down till I got this kind of voltage, and it really was not very satisfactory. And maybe I'll try it again with just using the ground, the little spring clip ground. Maybe that'll be better. I might try that. I'd have to find a place to touch that to the circuit, I guess, but I can figure that out.
Have to do a presentation somewhere along the way. You think about measurement techniques and what have you. That'd be an interesting conversation, because it always crops up when you start dealing with this kind of low voltage stuff.
Yeah. What I was hoping to be able to do, I haven't. The circuit has the feedback circuit here, and Charlie Morris did a thing where he actually set this up for negative feedback. And what it did, when you do this and calculate it properly, and the resistance value is related to the source impedance and the load impedance. And when you do that, what it does is it takes, let's say, this curve and moves the bottom up higher. It smooths. It gives you a much better gain. Like this is only goes out to 15 megahertz. Looking at it at the 30 megs at the end of the HF band, it's virtually, well, it's really low. It's down around 30 dB. So you've really knocked down the signal. So if you put the feedback thing in, you can pull this back up. I might, if I can do that and make some sense of it, I might just bring back some pictures sometime and show that. Anyway.
Oh, that would be good.
I just wanted to show what I'd found out that.
Well, I'm glad you did, Michael, because I find sometimes too I come back to a spice simulation and I think, what the heck is going on here? Like last week or last month or whatever, the real world and spice agreed, and then it didn't. And you've changed something, and it's so subtle the change, but it throws you for a loop. The other thing is, well, sorry, one other point. When you take this circuit and you calculate what the gain should be, theoretically it should be the impedance presented to the crystal, the collector here, divided by the emitter to ground impedance. And given this emitter resistor is totally bypassed, that should have been, I was talking last time, 340 ohms, which is what the collector looks like electrically, supposedly, divided by the small RE, which is 626 divided by the emitter current, which is 26 divided by 10 in this case. So it should be 2.6 divided into 340, which gives you 40 odd dB, not 37. So it's out a bit, and I would attribute that to the fact that the 340 ohms is wrong, but I don't know. I have no idea. Dave, you had a comment?
Yeah, Michael, you've piqued my interest in terms of the measuring capabilities of the scope. So what I could do, and I'm looking for a reason to turn my gear on and actually learn to use it again. So what I could do, I've got a fancy schmancy signal source, calibrated signal source that I haven't actually used much. I think I powered it on just a couple of times. I bought it just before I got into the shack move thing. So what I could do with that, I could do some experiments with the scope where I could feed that source directly into the scope using, a 50 ohm coax cable terminated at the scope, and see how low I can go. And I can see a proper sine wave. Then I'll use the scope probe at that level, and I'll see whether I can see it using the scope probe. And my guess is Peter's right. You're not going to see it. You're going to see gibberish. And maybe I can tweak it up, turn up the amplitude to the point where I can see a sine-ish wave without the, what you're seeing there. And that might be a good ballpark measurement to see what the sensitivity of that scope is.
Yeah, it'd be interesting. I sort of probably should do the same thing. The other thing is Al Walk in his W2AEW, he has a video where he talks about putting a 50 ohm termination at the scope. Plus he fiddles around with ways to connect. He basically, what he does, he cranks up his signal out of his signal generator quite high, and then attenuates it down and does that kind of thing as well. So I'm going to go back and have a look at what he's done and see if that makes any difference to what I'm doing. Yeah.
If you find that video, post the number for us.
Sure, I've got it somewhere. I'll have to find it. But yeah, there's a lot to learn here.
Well, that's good. Okay. Yeah. Thanks for that, Michael. Appreciate it. That's good. Ken.
Yeah, Michael, when you put the feedback in, what it actually does is it broadens the frequency at which the amplitude or the gain will flatten out. So when you're actually raising the lower end of your gain, you're actually flattening out the curve.
Yeah, what I was trying to say is it's at this point, this goes up, this end goes up. I think this, you would think. There's a woman, Mateo, is that her name? Somebody who's done a whole bunch of stuff on amplifiers and selecting components for them and whatnot. And she's got a couple of videos on the frequency performance of amplifiers, and she points out that the emitter capacitor, the emitter bypass capacitor, apparently determines the low frequency response of the amplifier, so the gain, and the output capacitance determines the high end, aside from the feedback stuff as well. So there's a lot to learn here.
Boy, that's interesting. I can see there's some more experimentation to see how that.
Well, I was going to do that, and the thing is, you can't. And she shows, the sort of standard bandwidth curve with the 3 dB points, and on the high frequency and the 3 dB point on the lower end. And she says, well, the 3 dB point is determined by any one of the capacitors. There's a bunch of capacitors. There's the emitter capacitor, there's the coupling capacitor on the input, and there's the I guess it's the capacitance between the collector and the base of the transistor, which can be shown as a capacitor to ground by using, I think it's a Miller thing or whatever. And she says, well, you pick, it turns out the emitter capacitor is the dominant one, and there's a couple other considerations for the output as well. So there's a lot to learn here and play with, but I guess what you have to do if you're going to do that with one of this particular circuit, you got to go way lower than 3.5 megahertz to see that, you would think, to see the drop off, because there's no drop off here to speak of at 3.5 megs anyway. So there's a lot to play with. Anyhow, that's really all I got to say. I won't take any more of your time.
Oh, I don't believe it. Forgery. Okay. I guess the last really up on the item here, Ken, you wanted to talk a little bit about the DIS's DCR?
Yes, I got the DIS's DCR from Kits and Parts going over the weekend, and it works very, very well. Let me just share my screen. Application. So you see that there?
Yes.
Okay. So there's the DCR on the right side there. It's about 2x3. Building wise, well, it took a little longer because it's all SMD parts, so had to do some soldering and cleaning up. But other than that, it went together quite well. Two items I had to play with is the stage that DIS is going to be attaching to the input of the DCR is a crystal filter, so it has an input of 200 ohms. So I had to wind up a 50 to 200 ohm transformer, and I'm using the SIGGEN as my VFO. DIS's design is set up for most DDSs out there that have a output of about 200 ohms. So in his circuit, he's got a DC blocking capacitor, and he's got a low pass filter, and then he's got a current limiting resistor into pin 6, which is the VFO signal. For the SIGGEN to work, it took me a little while to figure it out, but what I ended up doing is I scrapped everything that he had. I put in a 75 or 14 dB attenuator to knock the signal down, and then fed it with a 0.1 capacitor. But I couldn't get the darn thing to work. And doing some Googling around, as it turns out, the 0.1 capacitor is way too big. It's offering too heavy of a load. So what I did is I pulled it out, put in a 10 puff capacitor, and it works like a charm. So I got that working over the weekend. I was going to do a couple of recordings, but propagation today was pretty crappy. But yesterday, tons of CW, tons of digital, and tons of voice, and it worked like a charm. Let me see if I can go to, and here's the board up close. Can you see the board?
Yes.
Okay. So those resistors and that one capacitor in the back there is the attenuator and the 10 puff capacitor. And it works really well, really well. And so I'm just waiting for Diz to release his crystal filter stage. It's going to be, what do you call it? Selectable bandwidth for CW SSB. And then he's also got a IF amplifier stage. He's using the Wes's, what do you call it? Hicus amp. And just waiting for those two stages to be available to try out and give it a go. And I think by the time Diz is finished doing his project, he's going to have a super hat.
Yeah,
So
yeah.
that is it.
Does the kit come with the connectors on the right-hand side, the white ones?
No, they don't.
Okay.
Only the stuff that's on the board comes with the kit.
Mhm.
That's how he's able to keep the cost down. You provide any volume control switches. If you want to use a power jack, plugs, anything like that, you have to provide it yourself. This kit's, I think his kit's going to be going for about $20 US. And it includes all the parts on the board.
Mhm.
Okay. Thanks, Ken. Anybody else got any comments, questions on anything tonight, or not so much tonight? Hi, Al.
Sorry, got to put my mic on here. I've got a question with the PARC SigGen. Maybe one of you gentlemen can help me. I've got a couple of spare boards that I picked up, and I'm getting ready to populate the components. And I ran into one thing that I don't know, but there's a rotary shaft encoder on this, and in the parts list, all it says is rotary encoder. I'm just wondering whether anybody here could maybe expand on what that is. I've got the manual here. Maybe I can share the screen. Let's see if I know how to do this. Okay, well, maybe not. How do I share screen?
Over on the left-hand side,
At the bottom.
the middle says share your screen icon right beside the hand.
Okay, got it. And there we go. Here's the schematic, and you can see here's the encoder. And
It's not showing.
I'm a little ignorant. I don't know whether this is a quadrature or whatever this is, but I need to buy one of these, and I'm wondering whether anybody can shed some light on this.
I can't. Ken, do you remember? I don't think there was anything fancy about that encoder, was there?
No, it's the typical one that we order from DigiKey. There's I haven't shopped for anything in town, but quite often when we're putting kits together, I'll try and order stuff locally. And Q Kits in Kingston is a great supplier.
Okay.
They carry a lot of stuff. Try and see what they have. I think their prices are pretty reasonable.
Okay.
Yeah, the only trick there, Al, is just making sure you got the right footprint, because some of the encoders may have different pins and different pinouts. And as long as you got the 3 and 2, where 3 is the, I think the 3 pins is the encoder, and the 2 pins is the push button.
Right.
So as long as you got that, then it should be fine.
Okay, well that's good advice. Okay, say I've got 2 of these spare boards, and I want to get all the components collected before maybe it gets hard to get some of these things. I'm probably only going to build one of them up right now, but I want to get all the components assembled as a full kit.
And if you want to, Al, I took my SigGen and I turned it into a VFO for a radio. So where I'm controlling a radio with it, and it's not simple to go and do, but it's got the outputs, it's got the LCD, it can be done as long as you understand how to program it.
Right, right. On the same note, I am going to need software to download to this. Is that available anywhere? I didn't see it on the website or in the files. Who would I contact for that? You, Dave, perhaps?
Yeah, it's on my GitHub. If you go to my GitHub page, all my sources there. You can. I'm pretty sure it's on the groups.io, isn't it, Peter?
I thought it was, but it's been a while since I looked at that. I can take a quick look while we're here.
I went and got it from Dave's GitHub site at one point.
It's probably
afterwards.
Yeah.
Yeah, I'm not sure if it's in there or not. Yes, it is. Okay. It's in the file section under PARC Projects, PARC SIGGEN, and it's a zip file. I think the last version was the one with the letter F in it, and that's the one that's there.
Great.
That's what I use, the one with the F.
Yeah. Okay. Any other comments, questions?
Yeah, I'm just going to share my screen for Al. Okay. Can you see that, Al?
Yeah.
Okay, so there's Q-Kits in Kingston. This is probably the one you want. It's pretty common. It's the they call it the KY-0 something, and a lot of people talk about this one. You can use it on the board itself. You can take it off the board.
I bought a couple from him. They're just down the street from me, and
yeah,
I went over there and bought a couple off, and I removed them off the board.
Yeah.
You just got to be careful with the pinouts, because that pinout, it's the same pins. It does the same function, but I got to make sure you map the pins to the rotary encoder footprint that's on the board, right?
Yeah, it's a standard pinout encoder.
Yeah.
Okay, that works well because I was going to buy the LCD from them as well, so I'll just build up an order.
Yeah, and they'll give you a price break too, depending on how much you spend. I think they're trying to be like a DigiKey. They'll give you free mailing at $100, and that's where I ordered most of our stuff for the SIGGEN.
And actually, didn't Kevin modify the code to have it work with the attenuator? Peter, was that you or Kevin?
Yeah. Kevin and I were working on that. We ran into a little bit of a snag with it, and then Kevin got busy.
Yeah.
Okay.
and the problem became beyond my talents or lack of talent. So unfortunately, Kevin's not retired yet.
Yeah, I know. Yeah, I know. No, I mean it sort of worked, but then I even forget what we were doing now. It's in my notes that I've actually stored on OneNote. I have to go look at it. But there was an issue with the code, Dave. It's like because it has to. I didn't want to re-trigger it all the time, and because of just the way the code was, I was trying to figure out where to put it in the code. That's all. It was
re-trigger what?
I forget. I have to go look at the details again. But it was a place of I know what I want to do, but the code wasn't set up to do it the way I want to do it. So I have to figure out and massage it a bit or something. But I mean, it sort of worked. Oh no! You know what? The issue was the reading the RF signal strength.
That's right. When we were sending
the attenuator works just fine.
Yeah, it's just when we sent the signal to say what the power level was, it wasn't being read properly by the SIGGEN code.
The SIGGEN doesn't read power though.
No, the signal that we were sending to it.
We were reading it. Peter had the RF power. We wanted to read it back in, and that was the issue, is because it's a state machine. but we need to read it all the time to read. Anyway, I'm just going by memory, but there was an issue about the attenuator worked just fine, and it fit in with your state machine, but reading the actual power and then displaying it as we changed it was an issue, and I have to go back and look at the details.
Yeah, because it's got, I seem to remember that Arduino has got a bunch of interrupts. So you just have to start another interrupt if you wanted to work in the background.
Yeah, it was something like that. But
Yeah,
because it was easy enough to add another menu selection and another state for setting the attenuator and doing all that. That all worked. But it was just reading the power was the thing that stopped it.
Yeah, it was my end that crashed.
Yeah, it was your end that crashed. But if you just want to add an attenuator to it, I have the code and a sketch of how to do it. It's not hard to do.
Yeah.
And you can put in, and it's set up for either 2 attenuators, or so you could put in like if you wanted to put it into like a DCR, like the project, the DCR, right? You could have 2 output channels, and each one would have an attenuator in it, so they're both getting the same signal to the oscillators to generate the IQ. Or you can put them in series, and then you just have one big attenuator, whatever. So anyway, it does work. So if somebody wants it, they can have it.
Just got to finish it.
We just don't, it just doesn't read the power yet like we were planning on doing.
I've already cut the holes for the second LCD there, so we got to get it to work.
Well, I'm trying to get it all in one LCD, so you don't need a second LCD.
Or did I?
No, I think we got it all in one line.
No, you didn't, Pete.
Oh no, you're right. I cut it into one. Yeah, you're right. I only did one.
See, we're trying to be environmentally friendly and everything else here. We're trying to like cram it all in, feature creep, right?
There it is. There it is. There. So the attenuator board's there. Into there. Dwayne will recognize that. And the LCD and the SIGGEN, and then the 8307 circuit up here.
So anyway, yes, if somebody wants it, I can have it. I didn't upload it to your GitHub, Dave, because I didn't know if you wanted it on there, or I could put it on the PARC site too, and then if somebody wants to take it further, they can play around with it if they like.
I think there's a way you could branch code.
There is. I just haven't had time to do it.
You just gotta. There's so much stuff, and you just gotta spend hours going to figure out how to branch code and do all that shit.
I did hours.
We went back and forth a couple of times there, didn't we, Peter?
Well, I didn't really know what I was doing. Once it didn't work, and I played around with a couple of things and tried different things, and then that didn't work. And then after that, I just tried anything and everything just because I didn't want to bother Kevin. I wanted to be able to figure it out. So I tried the bulldozer method, and it didn't work. And finally, I had to throw my hands up and say, Kevin, help. Anyway.
Pete, you got all the time in the world and an inheritance to spend.
Yep.
We got a couple of Arduino experts in our group, so I don't need to become one of those. All right. Okay. I guess that's about it for tonight. Any last comments?
Yeah, I just want to let people know that next Tuesday is a club exec meeting. I've been invited to state our case to see if we can get the club to front some money for the kits for the DCR.
Okay.
And I'll let you guys know next week.
Good.
Sounds good.
Could you post a message on the forum or something in terms of what does that mean if they fund us? Does that mean we're on the hook for support for them, or they can control what we do?
No. What we're doing is we've put a 20 kit limit on the virtual buildathon. If anybody wants kits after that or time after, we'll have to make arrangements. But the 20 kit limit, we're asking if the club could supplement some of the costs, say $20 each. So, for example, if there's 20 kits, I want to see if I can get $400 to lower the cost for everybody who's participating.
And that'll be just for members.
It's free to ask.
Yeah,
That's for what?
for members.
Yes. So
It's
if
only
you're,
for members.
yeah, if you're not a member, you got to pay the membership.
Which has always been the rule.
Yeah.
To participate, you have to be a member.
Yeah.
So
Anyway, so we'll see. You don't ask. Club's rich, so I don't see why not. But anyway,
exactly, they got lots of money.
won't get upset until next week. So
Right.
we'll have a different conversation, right, Dave? So okay. All right. Well, thanks everybody. Unless somebody else, that's great. Thanks for joining us tonight, and kind of went over what we normally go over, but us retired guys have nothing else but to do but to talk. Okay. 7-3, everybody, and don't forget we got the regular club meeting on whatever date it is, the 16th, 16th of December, and then we're back in for the AF Mixer with Eric on the 6th of January.
Get your mic fixed.
What does AF stand for?
Pardon me?
What does AF stand for?
Audio frequency, because we're pretty cool, eh?
Yeah. Very good session tonight, I thought.
Pardon me?
Very good session tonight, I thought.
Oh, I thought so. That's good.
That was good.
And
Get
Eric,
your mic fixed, Eric.
did Eric talk? It's been a great night tonight.
Yeah, it's been excellent.
We can type.
Night, everybody.
Good night.
All right. Night, everybody.
Night.
Night. 7-3.
Hey, Peter?
Yeah.
Hey, I just updated my blog with a simple tracking generator for the Tiny ESA if you want to go and take a look at it.
Oh yeah, I didn't look today. I usually pop over your site there every couple of days and see what you've been up to. So I'll definitely do that. Actually, I got a bunch of stuff I could probably write up and put. I haven't put anything on mine for a while either. But that'll be an interesting read on that, Dwayne. I'll make a note there too. Tracking generator. You know, is Dave still there? Oh yeah, you know Dave. If the VNA that's out there now, and then I tell you, we bought our spectrum analyzers at the wrong time.
No, I don't know.
I think we did the right thing, but
No,
it would have been a lot harder.
happy with mine because you know what, the noise floor and it's calibrated and I'm sure those other machines are good enough to use for what we do. It's good enough.
Yeah.
But I like to have a good reading, right?
Oh, I don't regret buying it. I'm just saying the decision might have been a little bit tougher to actually go out and buy one if the
I hear you. Well, it's like my signal source, right? For years, I've been monkeying around trying to get a precise level to say, okay, this is my level. Now I could make measurements relative to it, right? And I struggled with that for the longest time, and that's why I pulled the trigger and I bought that signal source, because now I've got a good source that I know what the output is, and I've got a measurement equipment that I know is reading right, so I can make proper measurements now, right?
Well, that's why it's important with the modification of that signal generator with the attenuator circuit to add in the RF reading of the voltage and then read it back in. That's why it became important. Who's that? Oh, Eric the second.
What signal source did you buy, Dave?
What's that? The signal. Yeah. 2122.
Yeah, I'm gonna have to kick out one of these Erics.
21.
Dwayne, what? Just quickly, and then what's in with your tracking generator?
I just picked up a cheap 35 meg to 4.4 gig RF signal generator off of one of the Chinese sites, like Alibaba or something like that, and a mixer. Works out real nice. Gives me a couple other options too.
Oh, cool.
I think I have sound.
Yeah, but everybody's leaving now.
I know.
Yeah, you got sound now, Eric.
Wow. Guess I could have done that earlier.
Anyway, cool stuff. Alrighty.
Okay, I'm gonna go. See,
Yeah.
Eric, you finally get your sound now. When
Yeah,
I'm
my
going, bonehead.
other laptop, I don't know, whatever. This one usually doesn't work very well, but it's working now.
Yeah, the camera is not very good. I got my PC in my shack here. I can't get it to work. The video's crappy, and it's open office. So to show a PowerPoint presentation there, sometimes it's challenging. That's why I had to go to my laptop here, because this works. It's Windows and it's got all the bells and whistles, and it works.
Yeah, you were getting some weird flickering. I noticed earlier, right? Your screen was bright and dim, like some sort
Yeah,
of.
like, you know what, on the camera, if I keep having to clean the camera because there's a spot there on my camera. It's on my screen, but if there's other picture on my screen, it's not there, so it's coming from my camera. Can you guys see a spot on my
There's one
camera?
right on your nostril.
Yeah, it's like, okay, the spot is right on my nose.
Yeah, it's there.
Right? That's
Yep.
coming from my camera's got some kind of a spot on it.
Use an external cam.
It's annoying. It's just, here's another spot here.
Oh yeah.
You know, it's just annoying, all these little spots, because I keep going and scraping the screen because I think it's a speck of spit or food or
Use an external
something
camera.
from my mouth.
Use an external camera.
Yeah, I do. I've got one of these little external guys here, but it's shit. It's just crappy. And I even bought some headphones for my, it's got a mic for my PC here, but it's what a pain in the ass.
Yeah.
I hate computers.
That's what I use. I use an external camera. I
Yeah.
don't use the laptop camera. But anyway.
Yeah, but you got to get a good one. On my office PC, I got a good external cam. Logitech cam's got a microphone built in, and it works.
That's what I'm
flawless.
using here. Is a Logitech with a built-in microphone on it. I went to buy another one, but they've really gone up in price ever since.
Yeah.
Funny, eh?
Yeah, because I went to Best Buy the other day looking at cameras.
Mm-hmm.
Holy shit, are they expensive?
Yeah, even going on eBay, they're not any cheaper.
It's like hundreds of dollars.
So I'll just have to keep this one. I take care of this one.
Exactly.
I wonder if part of the problem with my mic here is that I noticed Windows had a failed. It was like in the middle of a failed update for a net framework thing. So I don't know.
Here's the flickering here.
Yeah, there it is. Yeah. I thought it was like maybe interference with your lights or something.
No, it's
yeah, it's when you pull back. Yeah, seriously. When you go forward, it stops.
Actually, your screen's really dark, Eric.
Yeah, that's just the camera. This is a really old laptop. I mean, I could do that, but yeah, that's funny. It's only when you lean back, Dave. What's that about? It's like
I have no idea.
It's the phone.
This is Tyler's old laptop that he used at college when he was in first year. So he wasn't using it, and I took it from him, and I said, "Okay, I'm going to use this."
Maybe your head is absorbing some radiation or something.
Yeah, it's that RF coming back into the house. It's kind of interesting what Kevin said. I never thought about that, about RF coming into the house. But people put antennas into their attics. Yeah, it's a few more feet away, but it's still close to you.
Yeah, I think 100 watts though. You're probably it depends how far away you are.
Distance squared, like you said, it could be 6 feet away if it's just on the other side of a bedroom wall, right? So.
Yeah, but if it's in your attic, it's going to come down. Your attic is how high from you?
Yeah, but it's going to be up in the rafter, so you're probably 6 feet away in your attic.
Yeah.
Yeah.
So I think 6 feet versus 1 feet, it's not that big. I know it's a 1/r² thing, but it's not that big of a difference.
You know what? It's becoming a big deal in Britain. Apparently, every ham's got to go through an exercise of doing the calculations. I haven't read
Yeah.
the full story on it, but if you look on the GQRP groups IO site, they're all it's full of chatter about it.
Yeah, because then what? Because I got houses all around, and so when even if I put a vertical up, I'm still going to be radiating into someone's house.
100 watts, by the time it gets to a neighbor, 100 watts you're not going to be in trouble. If you're going to be pumping out a kilowatt, you might want to do some math.
Yeah, yeah.
Anyway, so other than that, what else is new? Anything?
That's it.
Before you guys go, I just want to try one last time with my mic, just so we don't have to.
Pardon, I can't hear you again.
What? You can hear me. Stop it. Let me just give me a sec. It'll only take a moment.
I don't know, Dave. Your shack looks too clean,
Too sterile.
sterile, and you know what? And it's also got an echo in it, which isn't right. So put a carpet down on your floor. Or something.
Yeah, that's a problem in my office too. I don't have enough stuff on the walls.
Yeah, put a carpet down.
Yeah.
It'll
No,
keep.
never mind. I'm still having problems here. So.
Why? What are you going to show us?
No. I finally did there's like a halfway done Windows update. I thought that was a problem, but it's every time on this particular laptop, all of a sudden, I mean, it's been working fine since when did we start this? April, May, or whatever. And now every time I log into Jitsi Meet, it says there's a problem with your audio device. And I looked through my drivers. There's been no audio driver updates or anything. So
hey, hit the unrecord button.
Hit the unrecord button. Yeah.
Are you recording this?
Actually, it was.
Yeah.
Yeah. No, it is.
Did